All right, hey Reese and Carson, this is section 6-7. We are already like 7 sections into the chapter, but keep in mind we skipped 2. They were 6-3 and 6-5, so this is like the 5th section or whatever that we've done. And this is called common logs, okay? So go up to the top of the paper, and let's put some stuff up here. Like we would have logarithms before, and log, I'm going to say log form up here at the top. And let's say we have log base 2 of 8 equals 3, and this is what we've done in the past. We change him into an exponential function, so this is exponential form. And what would he look like in exponential form? 2 to the third equals 8. Usually we have an x there in that spot. That's fine. That's fine. So 2 to the third power equals 8. Those go back and forth between those forms, okay? Now, we're going to look specifically in this section at the bases of the log function, okay? So in this example right here, what was his base? For this function. Yeah, his base was 2, okay? So that subscript number is always the base, and when you are dealing with a common log, so this entire section, all we're going to be dealing with is common logs, and every common log has a base of 10, right? So common log, when they talk about common log, common is the base 10 system, okay? Logs have a lot to do with like the way that we count, okay? And I've talked to you before about logs, how like we count in units of 10, right? So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then as soon as we get to 10, we start back over at 11, 12, 13, 14, 11 is kind of similar to 1, 12 is similar to 2, etc. It's just units of 10s, right? So the log 10 system is a common log. Those are common units of measure, right? And I've told you before that sometimes they will have just log of x and they won't have a base number in there. And if they don't have a base number, we assume that it is 10, right? That's like the default. If there's no number there, we assume that it's a base of 10, all right? So they will use that notation down below. When you see log, just know in the back of your mind it has a base of 10. It's not even a bad idea to put a little subscript 10 in there to help you out. So that's kind of how that works. Those are called common logs. What's up, Josie?
So I say if no base, assume base is what?
Base is 10. If there is no base listed, you assume that it has a base of 10. Okay? All right, so here's what we're going to do. We're going to go to example 1. Don't type this in yet. It says use your calculator, but don't type this in yet. Ready? Okay? They want us to use a calculator to evaluate. Don't type it in yet. Romeo, don't type it in yet. This is log 5, okay? In the back of our minds, we're going to do this. We're going to do some estimating to see so that when we type this into our calculator, we know if the calculator did it right or not. So we're going to do some estimating and figure out what this number should be about, all right? So log 5, and just like we would do before, we're going to say equals x, but what's the base of that log?
10.
I just said 10, right? Okay? If I make this an exponential function, this says 10 to the x power equals 5, right? Agreed? Happy with that? Okay, now, let's do some guesstimating here, all right? So I'm going to go over here, and I'm going to plug some numbers in. 10 to the first power is 10. No, is 10. Let's go back up and go 10 to the 0 power. What's 10 to the 0 power?
1.
1. Everything to the 0 power is 1. 10 to the second power is 100, right? I want the number 5. 5 lives right here, somewhere in between 1 and 10. So I know that x is going to live somewhere between 0 and 1. This is saying what power of 10 will give me 5, right? You think it's a half?
Yeah.
Well, a half would mean 10 to the 1/2 power is the same thing as the square root of 10. And you don't have a, like, the perfect square root of 10 doesn't come out, right? Okay? But we're going to try to figure out what that x has to be in order for it to be close to 5. So let's just type in log 5, and let's figure out what he is. Okay? Type it into your calculator. You just have a straight log button, locate where he is, log, and type in 5. Log 5. What do you get? 0.69, what? 89. I think it's 990 if you round to 4 decimal places. If you round it, it'll like round up that way, okay? We're going to do to the nearest 10,000th, which is 4 decimal places, okay? All of these are going to be 4 decimal places. Just because they are small numbers and we round to 4 decimal places. That's what standard is for logs, okay? So 0.6990. Now, is that number in between 0 and 1 like we said? Yeah. Okay, let's go over here to the second one, which is log of 0.3. What?
I don't have that button.
L-O-G? Yes, you do.
I have in log.
Like ln?
the shift
Yeah.
button.
I have L and separated from my log.
So you hit it twice.
What do I do with the parentheses?
Bing bong.
I haven't had to.
If you're gonna put stuff after the 5, you will have to close the parenthesis, but if that's all you're typing, you don't have to do that. Okay? We'll talk about that parenthesis thing later.
So
Okay?
0.69?
Yes. 0.6990. Yep. 4 decimal places. Okay. Log base 10 again, right? Equals x. So this is saying 10 to what power will give me 0.3. Let's go again. 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. Where does 0.3 live? Right here. 0.3 lives over here, which means that my number for x has to be a number on this side of 0, which means it's going to be negative, right? Okay, so type this in. Type in log of 0.3. You should end up with a negative number, right? 5228 if you round, right? Is it 8 if you round?
There's a 7 after the 8, so it's a 9.
Yeah. Oh, so it's a 9? Okay. 29. There you go. Okay, that's going to be your answer. Just typing it into the calculator, but this is what it means, right? 10 to the negative 0.5229 will give me 0.3. Make sense? Okay? All right. Now, let's go down and let's talk about some story problems here. Example 2. The loudness of a sound is measured by this equation, okay? Where I represents the intensity of the sound and M represents the minimum intensity that your ear can hear, okay? You guys can hear different intensities of sound than I can because I'm old, right? Like I'm older than you. So there's certain pitches of sounds or certain intensities of sounds that you guys can hear that I cannot. That's just the way that it works, okay? So what we're going to do is we're going to plug some stuff in. It's going to give me some information, and then we're going to find the loudness of the sound, right? Residents living several miles from a concert venue can hear the music at an intensity of 66.6, okay? We've got to figure out what variable that goes in for. 66.6 goes in where? Into this equation. Nope. Just I, that's just the intensity, right? It says the intensity, okay? How many times the minimum intensity of sound detectable by the human ear was this sound if M is defined to be 1? So they're saying M is a standard 1. They want us to basically find the loudness. They want us to find L. So we're doing 10 log of 66.6 divided by 1. Okay, now, some of this stuff we can do in our heads. What's 66.6 divided by 1? It's just 66.6, so you don't even have to worry about typing in the 1. So you want to do 10 log, or if you need to put a times symbol in there, you can. 10 times log, that's what that means. 10 times log of 66.6. Okay, 18.2, what did you say, 23? 24? 25. 25, if you round, right?
Are we just rounding to that? We still have to round.
Oh. Yeah, we better do 4 decimal places. Okay, so 2 what? 2, 3, 4, 7. Yep, we'll do 4 decimal places because I told you that. Okay. So if I calculate that, whatever, it's 18.2347. Okay?
Okay, that's how you do it.
You have to type in the 66.6, then take a times log, like log of that, then take a times 10 if you're going to use that.
No, on here I have to take log and then I have to have the 66.6 and then I have to put the times.
Yep. You have to do it
Because I got a
backwards.
little confused.
Yes. So 18.2347, but what units are on the end of that? That's loudness. Decibels. That's in decibels. So they gave us an intensity of 66 decibels, and what they're saying is that loudness is 18 times what the minimum we can hear. So it's decently loud, right? Okay, let's go down here. These are going to be the type of problem solving. Woo! Something just happened. I don't know. Hold on. Un momento, por favor. We got HDMI cable fell out. Give me a moment. Plug it back in. I stepped on the wrong thing. Okay, so this guy. This way a second. I'll show you. Example 3 is, we've seen examples like this. Oh, come on. It doesn't like me very much today. I don't.
Oh, looks like we should just have a study hall.
It doesn't like me very much today. There we go.
So you wanted to do homework.
Okay. All right, example 3, example 4 are going to be similar to what's on your homework assignment. Here you go. Okay, ready? I'm not going to touch it. Okay. Solve 4 to the x power equals 19. This is our problem that we're doing. Here's our equal sign. And we've seen problems like this before, and our strategy was we look at the 4, we look at the 19, and we try to get them to be the same number, right? Okay? But like the problem is 19 can't be written as like 4 squared or 4 to something or whatever, okay? So let's do some guesstimating here, right?
So is it basically just
Okay.
solving and
4 to the 0 power is 1. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. Okay, I want that number to be 19.
2.5?
19 is going to be like here, right? 19. So my number for x has to be an answer between 2 and 3. We know that, right? Some of you guys figured that out right away. Okay. Now, when you can't get these to be the same base, here's the trick. 4 and 19, you cannot make them the same number. Here is what you do. Here's the strategy. Ready? What you're going to do is you're going to put a log in front of both sides, right? Okay? Do you remember before when we would have log on both sides and we would cross it off? This is just doing the reverse of that. This is inserting it in there, right? If we can take it off of both sides, we can certainly insert it in there, right? Okay? So what we have now is log of 4 to the x power equals log of 19, keeping in mind that that base is 10, right? Okay, so this is stuff that we can do on our calculator. And then the reason why we want to do this is because I'm trying to solve for that x, but I can't solve him if he's up in the top. But if I have a log there, where can he go?
To the front.
In the front, right? This x can come down here to the front, so it looks like x times log 4 equals log 19. Okay, and then how do I solve for x? This is x times log 4, right?
Log
What's the
of
opposite?
4 and log of 19.
Divide by log 4. Divide by log 4, okay? Now, Caitlin wanted to figure out what those were, like as decimals to start with, right? And you can certainly do that. But I just like to divide it over and then just enter it all into my calculator at one shot, okay? So x is going to be equal to log 19 divided by log 4. Now, problem, okay? Johnny was kind of on the same boat, and log 19 divided by log 4, here you go. I'm going to show you two things that you don't want to do. Log of 19 divided by log of 4 is not the same thing as log of 19 over 4. That is not true, right? This would end up being the minus of it, so you can't do that, okay? So we don't want to write it like that. You have to type in log both times. Now, on most of your calculators, what it's going to do is you're going to type in log, and it's going to open up parentheses. Yes? And you're going to type in 19. And if you do not close this parenthesis and immediately do divided by log 4, it's going to give you the wrong answer. So this, Mackenzie, when you were asking me before, this is a scenario where you have to close off the 19 before you hit divided by log 4. Make sense? Otherwise, you will not get the right answer, okay? If you type that in, what do you get?
2.1239.
1, 2, 4, 4, 0? 4, 0, 1, 2, 4, 0. Okay, if we go 4 decimal places, there he is. No, just wait. No, just wait. I know what you're doing, but no.
Same like the last
2.1240. Now, we guesstimated that number was going to be somewhere between 2 and 3. Were we right?
You know,
Yeah, I think so. 2.1240. Yes, wonderful. Okay? All right, now, this is a little bit harder on this one. Okay, we have a less than symbol. Doesn't change anything. Okay, but my two base numbers that I have are 3 and 7. Yeah? 3 and 7. Okay? Can you change those to be the same number? Like 3 squared is 7. No, not true. So what do? Log both sides, right? Put a log, okay? And the reason why we put that log of 3 to the 5y is less than, don't forget your symbol, log of 7 to the y minus 2 power, okay? And the reason why we put the logs there is because I want to be able to pull this guy down in front and pull this guy down in front, okay? So when we do that, 5y comes down in front times log 3 is less than y minus 2 times log 7. Now I get really picky when I pull that y minus 2 down in front because I want you to put parentheses around the y minus 2. Otherwise it just looks like the 2 is times log 7, right? Okay, so I get really picky about that. All right, now we got kind of a mess here. And I'm going to get rid of some of my loggy stuff. Okay, which side is the less complicated side?
That side. 5y side.
The 5y side, because this has two pieces, right? A y and a 2. So what I'm going to do is I'm going to make this easier by dividing log 7 over to the other side. Divide by log 7, okay? I want to put the two logs together and get rid of them, right? Log 3 divided by log 7, yeah? Okay, so this is 5y times, what's
Divide by
log
5y.
3 divided by log 7?
2.5646.
2.5646.
How do you get log 3 divided by log 7?
Just type in log 3 divided by log 7.
There's no 2. It's not 2 point. It's 0. It's just point.
Oh, 0.5646?
Yes.
I'm sorry. 0.5646. Okay, that is what the log 3 and log 7 was, right? Less than, what's over there on that right side? Y minus 2, that's all. Okay, all right, now what can we do to do some mathy stuff? Nah, I mean, you could. What?
Add y over.
Not quite. Not quite.
Subtract the y from the
Subtract
other.
5y.
Can we do 5 times this number and combine the numbers together?
Oh, yeah.
Can we do that? 5 times that? Okay, so what's 5 times the 0.5646? 2.8228?
9.
9? And there's a y on the end of that, right? It's that y, because we took 5 times the 0.5, is less than y minus 2. Okay? Now, how many terms do we have at this point? 1, 2, 3. Okay? 2 of them have a y on them, so we want to get them together, right?
Subtract the y over.
Okay, I'm going to subtract this y over, all right? Now, this is where algebra kids get really confused.
Minus y.
What number is in front of that y that we're subtracting? 1. So this is 2.8229 y minus 1y, which is 1.8229 y, right? Is less than negative 2. Okay, now what?
Divide the 1.5.
Divide by 1.8229.
Wait,
Divide by
oh,
1.8229.
minus
So y is less than
Wait, I'm confused.
what?
I'm confused.
Where?
Minus that y?
Yeah, we minus this y over here. Minus y, minus y. So when we minus 1y from there, it's instead of 2.822, it's 1.822, yeah? Yeah? Okay, now we're dividing by 1.822. Negative 2 divided by 1.822 is something. Ah, come on. Negative 1.0972. Yeah? Okay. Something like that. Yeah, very nice. Did we divide by a negative ever that we needed to flip a sign? I don't think so. I don't think so. But if you do that, you have to make sure that you flip a sign. So y is less than negative 1.0972. Yeah? Okay, good. Beautiful. Okay, last page, change of base. Okay, the very bottom of your homework assignment is going to be a change of base, and this is very easy. Okay? Some of your calculators think in bases other than 10. You can make them do that. Like Romeo is so excited that he can do that. Whatever. Eli sits over where Josie's at, Eli Carr, and he's like super pumped because he has like a brainiac calculator, and he's like so excited that his calculator does
All I have to do is this.
bases other than 10.
He has
But
to charge his-
for us normal people
the cool kids.
that don't have the
For
cool
the
calculators,
gamer kids, obviously.
I think my
we have a log button. I know. I like your calculator. Those are the best kind, right? Okay. The best kind, you know.
This is-
So for the normal calculators that can't think in bases other than 10, we need a method of being able to type in and solve log base 3 of 20, right?
So I
Okay?
just type
And
in.
your calculator can do it. Nope, you're not going to type it in.
Why?
Log base 3 of 20, here's how it works. It's very easy to convert this to a base 10. Here's how it works. Ready? This is equal to, okay? You're going to divide two logs, log of something over log of something, and you're dividing them, right? Okay, ready? This is very easy. The base number for the first one is what? 3. It goes to the basement. So log 3 goes on the bottom. Log 20 goes on top. So the base number goes to the basement, The top number goes, like the number you're taking it of goes to the top. So these are base 10s now, and you just have 2 logs. So we do log of 20 divided by log of 3, and that's all. And what do you get?
1.
2.7268.
2.7268.
I typed in the same one twice. Okay, that was my
Okay,
mistake.
keeping in mind that this actually means 3 to what power gives me 20, right? 3 to the second power is 9, 3 to the third power is 27, right? So I know that my number is going to be somewhere in between 2 and 3 if I want 20, right? That makes sense? Okay, let's do one more example like that, even though they don't give us, let's say, log base 5 of 32. If I want to convert that to a base of 10, what's that look like? Log 32 over log 5. The base number goes to the basement. The top number stays up above. And you just do log 32 divided by log 5, making sure that you're closing that parentheses off after the 32, right? 5 to what power gives you 32? It's somewhere between 2 and 3. 3, 4? Very nice. There you go. Okay? So, us normal people, if we don't have a calculator that will do that, we can very easily change it to tens and just do some division, okay? That's all.
Do it the smarter way.
Do it a better calculator. Okay, so, you guys don't have this paper yet, but I'm going to give it to you. Watching this video, evens on skills practice, evens on practice. So, evens both sides, there you go.
How much did it cost?
All right.
Do we have
30 bucks?
You don't have a homework page, I'm just saying that for the people in the video. Bye, people in the video.